Hey everyone, today I'm going to show you how to do recursion in Python. We're going to choose a problem to solve, and then I'm first going to show you how to do it using a for loop and a while loop, and then finally I'll show you how to do the same thing using recursion. So we're going to create a project called recursion. The problem we're going to try to solve today is getting the factorial of a number. So the first way we're going to try to approach doing this is with a for loop. So we're going to create a function called factorial4, just to say that it's a for loop. And now we're going to find out how to input a number into this function. Let's call it x, and get the factorial of that number out. Okay, so now that we have our function, let's figure out how to solve factorial using a for loop. We're going to want to store our answer somewhere, so let's start with an answer variable. And what we're going to do is we're going to set it equal to 1, because we know at a minimum the factorial is going to be equal to 1. So because 0 factorial is 1, 1 factorial is 1. So we know that at a minimum, the answer is going to be 1. And when you think about factorial in your head, what you probably do is you multiply, you take 5, let's say 5 factorial, you do, okay, 5 times 4 times 3 times 2 times 1. Okay, so we know that at a minimum, in that multiplicative process, it's going to at least have to be multiplied by 1. So let's start with answer equals 1. And then now what we're going to do is going to go make a for loop, and we're going to start with x, the value we're passing in. We're going to stop when I has finished being 1, so when it gets to 0, and we're going to go down by 1. So we're doing a for loop kind of backwards. So we start at whatever x is, the value you want to find the factorial of, and we're going to go down by 1. So 5, 4, 3, 2, 1, stop. So now that we have our for loop, we have to think about what we want to do inside of that. We have answer equals 1 right now. Let's say that you choose a number 5. You probably go down backwards, starting at 5 and multiply. So 5 times 4 times 3 times 2 times 1, right? So we're going to do the same thing here. And because I is going to go down by 1, just like I did out loud, it's going to start at 5, and then the next time it goes through the loop, it's going to be 4, 3, 2, 1. What we want to do is take our answer, and it's going to store the value in each iteration, and what we want to do is take answer and multiply it by I in each iteration. So times equals is a little bit of like syntactic sugar in Python. It pretty much just means answer equals answer times I. And so let's think about the case where x equals 5 here. So the first time we go through the for loop, I is going to be set equal to x, which in this case is 5. And then we're going to multiply answer, which is 1, by 5, and it's going to be equal to 5. So at the end of the first for loop, answer will be equal to 5. We're going to go through the for loop again, and I was just 5, so we decrement by 1, and it's going to be 4 now. And then we're going to multiply answer, which is now 5 from the last time we went through the for loop, and we're going to multiply that by 4. So answer is going to be equal to itself times 4. 5 times 4 is 20. Then we're going to go through again. I is going to go down by 1, so it was 4 last time. Now it's going to be 3. And we're going to take the answer, which is stored 20, multiply itself by 3, 60. And it's going to keep going. Next time you see 2, 2 times 60 is 120. It's going to get to 1. 120 times 1 is 120. And then it's going to stop at 0 and say, okay, time to leave the for loop. And then what we can do is just return the answer. Now, if you think about it, we really can actually stop after we finish the loop where I is equal to 2, because really what we do in the last loop, no matter what, if we leave it at 0, as this is 0, is we just multiply the answer by 1. That's not going to have any effect. So we can actually stop when it gets to 1. We can break out of the for loop, so we don't actually have to do the loop when I is equal to 1. So now let's test this out. So we're going to say a equals factorial 4 of 5. And then we're going to print out a. And we should expect 120, and that's what we got. Awesome. So now we're going to do this with a while loop. Let's call it factorial while. And it also is going to take x. Great. Again, we're going to start with the answer as 1. We're going to do the same thing that we did in the for loop, but we're actually going to use one variable fewer, and that variable is going to be I. We no longer need I, and I will show you why. So we'll do while x is greater than 1. This is going to be very similar to the for loop. We could do greater than 0, but again, as you'll see from the last time, when it won't make a difference if it's 0 or 1. It would be multiplying by 1. You'll see that. So we're going to say while x is greater than 1, and then we're going to say answer times equals x. Except this time, we're going to decrement x after the loop. So what is happening here? It's pretty much the same thing as in the factorial for function, except instead of having the variable I, we're pretty much just using the x that we passed through to store what the current value is at when we loop through it. I'll go through this again with the example where x equals 5. So answer is equal to 1, and then while 5 is greater than 1, we're going to take answer 1 and multiply itself by x, which is 5 in this case. So 1 times 5 is 5. So now answer is equal to 5. And then we go, okay, x is going to equal itself minus 1. So x is 5 here. We're going to subtract 1. And now at the end of this, x is going to be 4. And then we're going to go through the while loop again. Okay, well, 4 is greater than 1. So we're going to continue inside this while loop. And then we'll say, okay, answer was 5 from the last round. So we're going to multiply answer by itself by 4. Because x is now 4. And answer will be 20 at the end of this. And then we decrement x again, and now x will be 3 at the end of the while loop. And you can see it's pretty much the same thing as the for loop, but instead of using I, we're just using the variable x that we passed through and decrementing that instead. And then at the end of this, we're going to return the answer. And now let's see what happens here. Both 120. Great. Now for the fun part, recursion. So we're going to make another function, Factorial Recursive, and it's going to take x. And so if you've never dealt with recursion, hopefully this will give you some insight, because factorial is one of the classic recursive problems that you learn when you're first starting off, and hopefully as you'll see in comparison to the other two examples I showed you, maybe the recursive way will make a little bit more sense. In recursion, you always want to think about a base case. You want to know when to stop. If you looked at the for loop, we knew that we had to stop when x got to the value 1. Or sorry, when I got to the value 1 in the for loop. In the while loop, it was when x got to 1. The while loop would stop when x got to 1. It would say, okay, while 1 is greater than 1, well, that's not true. And it would break out at the end of that. So it would go down from whatever x was, get to 1, break out. Using the for loop and while loop as an example, we can know that we should stop when we get to x being equal to 1. Normally, the base case will be an if statement, and that's when you break out. So in this case, let's start with this base case. We'll say if x is equal to 1, we're going to have to break out somehow. In this base case, it's essentially, we should imagine that we've just called the function one time. So let's imagine we're just dealing with the base case and we just pass in 1, right? Well, what should 1 factorial be? 1 factorial should be 1. So let's return 1. And before we start doing anything crazy and thinking and looking more into how this recursion is going to work, let's just test this out. Factorial recursive. And let's just pass in 1 and print it out. Great. It's going to be 1. If we pass in another number, it's just going to be none, because we're not returning anything. So right now it only works for 1. We have a base case. It only is we're going to work when we pass in the number 1. We know what happens when x is equal to 1. We know that for 1 factorial, the answer should be 1. So it's easier just in recursion to start with a like a smaller case and build upward when you're thinking about how to write the function. Now we have to think about the case. Let's build up. Let's try 2. What should it be when x is 2? Well, we could just say else if x is equal to 2, return 2. But that's no fun. You could just make a bunch of if statements, and that's not recursion. Recursion is when a function essentially calls itself multiple times to get a answer or value that you want. So we don't want to do that. Let's think about what we can do. And I'll give you a hint. What we can do is we can look back at the other two functions we made and think about what we did. What did we do when it wasn't... What did we do during each iteration? Well, we multiplied the answer by itself. What we're going to do is we know that we have to call in recursion, because that's how it works. We know we have to call factorial recursive within itself. So let's get that call ready. We know that we have to call factorial recursive because that's how recursion works. But we don't know what we're going to pass in here yet. And we don't know what we're going to return yet. So let's think about the case again where we passed in 2. So we passed in factorial recursive 2. We're going to come in here the first time we call this, and x is going to be 2. We're going to say if x equals 1. Well, that's not true. So what are we going to do? I'll give you a hint, and we're going to pass in here whatever is now minus 1. We're going to decrement just like we did in this case, and in this function, and also in this function where we go down by 1 each time. We're going to decrement. So we passed in 2, and then we're going to say, okay, 2 minus 1 is 1. And we're going to call factorial recursive again, so it's going to come back to itself. Now x is going to be 1 because we just decremented 2. And it's going to say if x is equal to 1, return 1. Well, in this case, it's going to return 1. So what can we do thinking back a step? It's going to return 1, and this value that we the result of this is going to be 1 right here. And we know that after this call, after this function calls, we know that we need to return back to the caller down here. What should we do to this response to get the answer that we want down below? Well, we can just multiply the value that it's currently at. So I know that sounds very confusing, and we'll go through this again, but I'm going to tell you that we're going to return this whole thing. Let's think about this again, already knowing what's going to happen that now that the function has been written. We're going to pass in 2, and it's going to come over here, and then we're going to, okay, x is 2. So x is not 1, so we're not returning here. Ignore the return for now. In fact, a better way to do it is let's set it equal to y and then return y. This is an easier way to think about it. So we're going to set y equal to 2, because that's what x is, times, and then call this function again, but we're going to do 2 minus 1. And that's 1. The way this gets evaluated is that it does the last thing first. So it's going to go down 1 level, and call factorial recursive with 1, and it's going to get to this base case and see that x is equal to 1, and it's going to return 1. Now it's going to come back out here, and this value is going to end up being 1. And if you remember, when we come back up from that return, x is still 2 from before, so this is really going to be y equals 2 times 1, because x is 2. So let's put this back. Let's just test this out to see if it's working. Yes, it's 2. And now I'm going to pass in 5 just to make sure that it works that way as well. Great. So the recursive case is probably a little bit confusing for those of you who have not done recursion before. So I'm going to do it one more time. I'm going to go through this with you again. And I want you to think of each time this function gets called as a frame kind of. It's its own independent frame with its own values. And we're going to practice this again on here, pretending that x is 5 again. So this is going to be the first call. This is going to be the second call, the third call, the fourth call, and the fourth call, and the fifth call. And you'll see what I mean. I'm just going to organize this here. Great. The first time we call this function, let's say down here when we pass in 5, we know that x is going to be equal to 5. So it starts off where x is equal to 5. In this case, x is not equal to 1, so we're not returning 1. And then we're going to say y is equal to, well, x is 5 right now. We know that it's 5, so it's going to be equal to 5. Or let's leave x now so you can see. So y is equal to x times factorial recursive, and x minus 1 is going to be 5 minus 1 because we know x is 5, so it's going to be 4 here. We're going to call this function again right now, with 4 being passed through. So let's go to the second frame. Let's think of it the next time it's called. Let's just pretend, let's forget everything we did for a second and imagine that it's its own call by itself, because it is. And so now we're going to start this off with x equals 4. And it's going to say, okay, is 4 equal to 1? No. So let's do y is equal to 4 times this function call again. But instead of being 4, it's going to be 4 minus 1, which is 3. So now, again, forget everything we just did. Imagine, right, we got to this call, factorial recursive 3. So now let's call this function with 3 down here. X is equal to 3. We know that x is not equal to 1 again. So y is equal to 3 times factorial recursive. And then 3 minus 1 is 2. So let's new frame again. Let's go down here. We'll get the call again where x is equal to 2. So again, x is not equal to 1. So it's going to go down to here. And we're going to do y equals 2 times factorial recursive. And then 2 minus 1 is 1. Finally, we're going to get to here. X is going to be equal to 1. So this last frame, this last call, x is equal to 1. So we're going to come to this statement, and it's going to be like, oh, we're finally 1. So instead of, it's not going to get to this at all. We're just going to return 1. So we return 1 here. And so when we return 1 from here, again, none of this is going to happen, and it's going to come back to this call above. This frame above is getting this response. So this returns 1. And then this value, this function call, the response, the return value of that is this. So it's 1. So we just sent 1 back to this stack frame, this frame right here. And now we could continue with this operation. So y is equal to 2 times 1. That's 2. So let's just say y equals 2. And we're going to return y. So and since y is 2, we're really returning 2. Now we're going to build up from the call that happened before it. And it's getting this value from the frame below. So this is actually going to be replaced with 2. And this frame can finally finish the calculation. And y is going to be 3 times 2, which is 6. So we're going to return 6. And then we're going to go to the frame above. The frame above can finally get its response because all the frames below have finished. And that value is going to be 6. Y equals 4 times 6, that's 24. And now it's going to return y, which is 24. And finally, we get to the last frame. And we're going to multiply, we get the response of 24. And it's going to be 5 times 24, which is 120. And it returns 120. And this, because this is the last frame, it's finally done calling itself and all of that. The caller from this last frame was down here. And so C is going to get the response, 120, and we print out C. I hope that makes sense to you. And I know it's very difficult, especially when you're first learning how to do recursion, to visualize this and think ahead of the game when you're coming up with your base case. But it's very key to just put all these things together, kind of think backwards in a sense. Start at the easiest component, the easiest way to solve your problem. So that, like, again, in your head, well, if somebody asks you what's the factorial of 1? Well, you'd be like 1 factorial. It's an easy base way to think about this. Another thing to note in this is that it actually doesn't work with 0, because when we call this with 0, the first time, 0 is going to come in here, and then 0 is not going to be equal to 1. So it's actually going to keep going down forever and ever and ever. And so what happens when it gets called forever is it eventually gets mad. Python, I think, stops at like 1,000 tries. Like I said, as we were thinking of all of these as stacks, in Python, if you get to 1,000 stacks, it's pretty much saying, hey, you probably messed something up when you were coding. I'm going to stop all this. Otherwise, it's going to use up all your memory and keep going forever. And we don't want that. And I'll show you now how that looks. I have to comment this out. And let's call factorial recursive with 0. Again, it's not going to work because it's never going to get to 1 in its base case. It's never going to get to that base case because it's starting below the base case. So it's going to do when the first time it gets called, x is going to be 0. Y will be equal to 0 times factorial recursive 0 minus 1, which is -1. And it's going to keep going down forever. It's never going to get to this base case in any of its calls and come back up. We'll run it, and we'll see recursion error, maximum recursion depth exceeded in comparison. It's a good thing that Python is going to catch this error for you, because then you can figure out that something's wrong, and your program just won't just run forever, and you will never, like, it'll tell you that, hey, you're doing this so many times, like, there's probably something wrong with your code. In conclusion, when it comes to writing a recursive function, you want to think small, start with the easiest, most simple base case, the thing that no matter what happens, your call is always going to hit that. In this case, it was 1, because that's the way factorial works. Whether or not it's 5 factorial, 10 factorial, 20 factorial, you multiply 20 to, like, by 19, by 18, whatever, it always gets multiplied by 1 at the end. So 1 factorial or 0 factorial, but we're putting that to the side right now. 1 factorial is the easiest number to get the factorial of, because it's just 1. You just return 1. So you start small, and then you think a little bit bigger. What would 2 factorial be? Well, you try to make your function that you just made with the base case work with just 2 factorial. How would you make it work? Because you know you're going to have 2 stack frames. So, and if recursion is really confusing for you in the beginning, it does help to try to do it in using a for loop or a while loop, although some problems will eventually get a lot easier to solve with recursion instead of for and while loops. Some problems are very hard to actually think of in terms of for and while loops, and recursion kind of becomes one of your really good friends in programming. I know it might be stressful in the beginning when you're learning recursive functions, but I promise you in time you will get better at them. It really does take practice. You just got to think about it in the same way I told you. Start small, and then you grow the problem a little bit bigger until you have a function that handles all of your cases. In this case, we had 1 base case. There are going to be recursive problems that take multiple base cases. The final thing I want to do is compare these functions a little bit more. Because I showed you this and how stacks work, because this is actually what it's essentially doing behind the scenes. Since I explained that to you a little bit, it may be no surprise to you that recursion actually ends up using more memory, because it needs to make each of these stacks. It makes 5 different stacks in the example that we had before, with x being 5. And in each of those stacks, it has to hold all those variables until it completes. So it's going to do the first stack, second stack, third stack, fourth stack, fifth stack, but it still needs to remember all the information from the previous stacks. So there's all that memory, or all the information needs to be stored in memory until it's done being used, and it's not going to be done being used until it finishes the deepest case, and then builds back, or like returns back up and starts, like, throwing out all the stacks. So recursion actually does take up more space, and the for loop and the while loop cases are going to be very similar. The differences are pretty negligible. So in the grand scheme of things, for loops and while loops are actually normally going to be more efficient, but that doesn't mean you shouldn't use recursion, because in most cases the differences in the memory it's going to take is going to be very small when you're working with big projects that can use tons of memory, tons of RAM. But if you're working on maybe a very, a small machine that only has a limited amount of memory, which is not very common nowadays, you'd probably try to find a solution that doesn't use recursion, because then it minimizes the amount of memory it's going to use. But there are definitely going to be cases where recursion is going to be easier for you to figure out how to use, and for loops and while loops will start looking ugly and messy when you get more difficult problems that you need to solve. I hope you enjoyed the video today and learned a little bit about recursion and how it works in comparison to while loops and for loops. And if you want to continue to watch tutorials like the one you just saw, please subscribe by clicking the button below. Thank you.